Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is job sequencing problem, and it is a medium level problem. So I believe that it is a very standard problem, but I haven't solved like much standard data success problems. So for me, it was also the first time solving this problem. So the reason I'm telling you this is because I'll be explaining you the way I thought about this problem. So let us quickly discuss the problem. It says that we have been given a set of n jobs where job I has a deadline and a profit associated with it. Right. So each job has a deadline and a profit. Now each job takes 1 unit of time to complete and only one job can be scheduled at a time. Right. And our task is to like earn the maximum profit, and you can see we have to earn the maximum profit, and when we do it we have to output the number of jobs we have taken and the profit that we have calculated. Right. So this is a task. Now the main criteria is to maximize the profit, but we also have to output the number of jobs that we have taken. So let me explain you with a sample test case. So let us take this one. Right. So what is happening essentially is they have taken two jobs which which has a sum equals to 60. How are we coming up to 60? Let us discuss this particular answer. Now there is one job which has a deadline 4 and has a profit 20. There is another job which has a deadline 1 and has a profit 10. Another job which has a deadline 1 and has a profit 30. And another job which has a deadline 1 and has a profit 40. So these are the four jobs that are available with us. So this is 1 comma 30, 1 comma 10, 1 comma 40, and the final one is 4 comma 20. So like now if you are at time 0, it is like most obvious that you would choose this particular job and complete it by in 1 unit of time, and that would be 1. So 1 is equal to the deadline, so that is we can complete this job because by the end of the deadline we would have completed this job. So the total profit that I have taken now is 40. Now my current time is 1 and this job is at time 4. The deadline is 4. I can complete it by time 2. So obviously 2 is less than equals to 4, and then 20 will get added to my answer. Right. So the total answer will be 60. Now if you have taken this job, you cannot take any other jobs, and if you try to take the any other jobs other than this particular job, then obviously the total profit will be lesser than what you have got now. Right. So this is the key idea. Now there is one thing that I initially thought, that was like to just sort the values, all the elements according to their profits, right? So this is will be a central idea. So once we do this, all the values will be arranged like this. So this is 40 and the deadline is 1. The second value is 30 and the deadline is 1 again. The third value is 4 or comma 20 because the deadline is 4 and profit is 10 or 20, and the final value is 1 with deadline 1 and the profit 10. Right. So why we have done this? We have done this to maximize our profit greedily, because we would obviously want to choose the values which has the maximum profit first. Right. So the first thing that we can do is we can choose this particular value. Now let me just maintain an array. So this array will indicate a very interesting thing: 0, 1, 2, 3, 4, 5, 6. So at the ith index, so the ith index is the ith time slot. This is just for the sake of discussion, and we will see how this particular thing will be useful later on. So the ith index will denote the ith time slot. So this is the ith time slot. That means if I am currently at time 0 and I want to do some job, so it will end at by the end of time 1, right? So I'll place that job here, right? Because I'm using the first time slot to do that particular job. I cannot use the 0 time slot to do any particular job because I will be initially at time 0. So when I want to do a job, I will first place into the first index because I will be doing it in the first time slot. Right. So this is how this time slot thing is working. Now you would observe for any value or for any index, like for example, let us take this one. Let us take this one. If I want to include this job, what is the best place to what is the best time slot to insert this particular job? So if the deadline is 4, my guess would be I would want to insert it into such a place such that the time slot is maximum. Why? Because if the deadline is 4, I can easily complete it at the 4th index, right? And why am I doing it at the 4th index? Because there might be other jobs after it as well which have a deadline either equals to 3 or 2 or 1, right? So I don't want to ruin their chances. So for example, there is a job with deadline 2 and the profit is 100. Again, there is a job that has a deadline 1 and the profit is 50, right? Now I have time slots like this. So this is the 0, this is 1, this is 2. Now let us denote that this is J1 and this is J2. So like I have sorted them according to the profits. So if I take this job, right, where do I place it? If I place it at this particular position and then I go on to the next job, I see that this particular job has a deadline 1 and there is already a job at time is equals to 1 or the first time slot. So obviously now I cannot take this job. So my obvious answer would be whenever I see a job with some X deadline, so this is the deadline, I would want to place it as far back as possible. So in this case 2 was free, that is why I can place J1 here. Now I see the deadline of this particular job is 1, so I can place J2 here and I can form my answer. Now let us take one more example. So if this is the case, 0, 1, 2, 3. What if I have a job with deadline 3, the profit is 100, again a job with deadline 3 and the profit is 50. So this is J1 now and this is J2. Now I can easily place J1 here because as we have discussed, we would want to place it as far back as possible. Now J2 also has a deadline 3, but I cannot place it at the third index because there is already a job at 3. So what I would do is I would find the next position where I can place it, right? So J2, so for example, index 2 was free, so I can place it at J2 index. Now this would be the general approach of solving this question. So what we have to do is for any job that I find, I would like to go to the farthest back index that I can place the job in and place it at that particular place. If there is no such index where I can place the job, then we cannot include the job into our answer. So like this would be the common idea. Now, how do we actually implement this idea? So while solving this problem, one thing that came to my mind was binary search. With the help of binary search, we can find the maximum index such that I can place that job. But the binary search is not going to work in this particular case. I'm telling you the reason why. So for example, if these are some indexes, right? So there can be a case where some value from here is taken, some value from here is taken, and some value from here is taken, right? So the array, so this let us say that this value is not taken. So like the array you can see does not have a definite pattern. For binary search to work, the array or the input should be either monotonically increasing or it should be monotonically decreasing, right? It should follow one pattern. But if the array has these variation, like one time it is 1, then 0, then 1, then 0, then 1, it is not following any pattern. So obviously binary search is not going to work. So this case is very well possible that we have a job order like this because there might be a job with deadline 5 and then but there might be a job with deadline 3 and there might be a job with deadline 1, right? So this order is pretty much possible and hence we cannot apply binary search on this particular problem. Now the second way through which I implemented this particular problem was using disjoint set. So you will see a very interesting application of disjoint set here. So let's say these are the indexes. So this is 0, 1, 2, 3, 4, 5. So if I have a deadline, let's say, so if my deadline is X, if I do find of X, it should return me the position where I can place the element or the job with deadline is equals to X. So it should return me the last position or the greatest position, right? So initially there are no slots assigned. So when I do find of 5, whenever I do find of 5, it will return me 5 only. So if I do find of 5 right now, it will return me 5, right? Now, after I have considered this as an option and I have scheduled a job at index 5 That means whenever I do find of 5 again, I cannot take it again, right? This is a very simple thing. So for example, I placed my job 1 here. Now I have to merge these two places. Why? Because the next time I do find of 5, I cannot take 5, I can only take 4. Right. So again I do find of 5. The greatest value that I can take is 4. Since I have merged both of them, it will return me 4. Again I place my job here, J2. Right. Now I have to merge these two places. So the next time I do find of 5, or even if I do find of 4, so the next time if I do find of 5, that will be equals to find of 4, and that would be equals to 3. But let's say I did the next job was with a deadline 2. So I did find of 2. So it will return me 2. Right. So the next job J3 was placed here, and these two values were merged. Right. Next time I did the next job was with deadline 3. Right. So I would do find of 3. It will return me 3. I place my J4 job here, and now these two would be merged. So the advantage with this particular approach was that since 2 and 3 are now merged, now for any value from 2 to 5. So if I do find of 2, find of 3, find of 4, find of 5, it will always return me 1 because all these values are merged into 1. Right. So it will always return me 1. That is the latest job that I can take. Now when I place my final job here, let's say it was J5, right? So these two values will be merged, and I cannot place any job at 0. So whenever find of x is equal to 0, that means I cannot place that particular job in any suitable position. So this would be the whole idea of the problem. So let me just quickly summarize what we discussed in this problem. So the core idea is to greedily sort the values according to their maximum profit, that is the maximum profit associated with them. Now I try to place the positions or the jobs such that they are as close to their deadlines. I would want to complete them as late as possible. Why? Because we have already discussed, if we do a job J2 early, then there might be some other job that could have taken its place, but now it cannot take because J2 has already taken its place. So we would always want to place any job as far back as possible so that more number of slots are empty from the first index till that particular index. Now we cannot apply binary search on this particular approach, on this particular problem, because the values are not monotonically increasing or monotonically decreasing, right? They are in some random order. So the next approach that we discussed was using a disjoint set where where find of x will give me the greatest index where I can place it, right? So this will give me the index where I can place it. Once I place it, once I use that particular index, I cannot use it again. So I will merge it. So I will merge my index with index minus 1. So index minus 1, because index minus 1 would be the next position I would want to go once my index position is taken, right? So this would be the whole idea of the problem. And since this is a disjoint set, whenever as I've already explained you in the example, these were two different trees that were merged into one, and now both of them give the parent value equals to 1. Whenever find of x value becomes 0, that means we cannot place any element there. That is why we can just not include that particular job. So this would be the whole approach. Now let me just show you the code for this particular problem. So what I've initially done is I've sorted my initial array. So I've used lambda function here so that I can sort it. So I can write a sort logic just here. So if a dot profit is equals to b dot profit, then I have to return. That means both of the profits are saved. I just return where the deadline of that particular profit is less than the deadline of the second element. So the first priority is to sort according to maximum profit. The second priority is to sort according to the minimum deadline. Now, if the profits are not equal, I just return a dot profit is greater than b dot profit. Right. So this is what we have to do. Now I create a disjoint set of size n plus 1, and I just initialize it with minus 1. So these are my two find and merge functions that I'll be using. But let us first discuss the logic part, mean logic part. So I've created my vector of answer because the question asks, because we have to return a vector of integers, right? So it will return two values. All of them are initialized to 0. So I used this variable earlier, but now it is not required, so I can remove it. So now what we have to do is we just have to traverse through all the values and I just find the value of x. So I'm just finding the deadline value. So it will give me the maximum value where I can place my job. So if x is equal to 0, obviously I cannot place a job at x is equal to 0. So I just continue from there. Now if I can place the job, I merge x and x minus 1 and I add my current profit to answer of 1 and I increment my value of answer of 0. So answer of 1 will be storing the profit and answer of 0 will be storing the number of jobs that I have taken. So let us discuss this find and merge functions. So the find function is a very simple and most used find function using path compression. So if disjoint set of a is less than 0, I just return the index a. Otherwise, I just return the disjoint set of a is equals to find of disjoint set of a. So this is just a one-line optimization for path compression. If you search it on the internet, you will find the explanation of this function very easily. Now let us discuss the second function that we have. So merge function, what it does is I'm just finding both of the values, and if both of the values are equal, I just return, and if a is greater than b, I swap both of them. Why am I swapping that? This is also because I want the parent to be the lesser value. So if there are two values that I have to merge, then the parent will be the lesser value, because I want to store the data of the index where I can place my next element. So the next element will only be placed at a lesser value than the current value, right? So for example, if I was merging x and x minus 1, let's say, so the next element would be placed in x minus 1. That is why the value of a should be less than b, so that I can take a as a parent. So I'm just doing the disjoint set of a plus is equals to disjoint set of b, and I'm setting the parent of b as a, right? So this thing is actually not required. The most important part is just that I just do disjoint set of b is equal to a. That is, I set the parent of b as a. So after this whole for loop is completed, I can just return my answer vector, and this would be the final solution of this problem. So I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and you can always unsubscribe later if you don't find the videos interesting. So till the next video drop, keep coding, stay safe, bye bye.